In this video, we're going to find the derivatives of inverse trig functions. So let's find the derivative with respect to x of inverse sine of x. So we're going to define y equals inverse sine of x. And we want to find dy dx. So we're going to take sine on both sides. We get sine of y equals sine of inverse sine of x. So this will give us sine y equal sine of inverse sine of x is just x. So we're going to take the derivative on both sides. So this is prime. This will be cosine y times the derivative of the inside, which is dy dx, equals 1. So we have that dy dx equals 1 over cosine y. So we have that sine squared y plus cosine squared y equal 1. This means that cosine squared y is 1 minus sine squared y. This means that cosine y is plus or minus square root of 1 minus sine squared y. So this is 1 over, we're going to pick the positive, so it would be square root of 1 minus sine squared y, which we define to be x. So we have x squared, and that is the derivative of the inverse sine of x. So if you do the same thing for inverse cosine of x, you'll just get the negative version, so it'll be 1 over negative square root of 1 minus x squared. If you want to find the derivative of inverse tangent x, we're going to let y equal inverse tangent x. So we have that x is tangent y, and we want to find dy dx. So if I take dy, so if I have d over dx of x equals tangent y. So we have, on the left-hand side, we have derivative of x with respect to x is 1. The derivative of tangent y is secant squared y times the derivative of the inside, which is dy dx. This means that dy dx will be 1 over secant squared y. So we know that tangent squared y plus 1 is secant squared y. So we'll just plug that in. And tangent y is x, so this will just be 1 over x squared plus 1. So that is the derivative of the inverse sine of x. That's the end of the video.